alpha and beta are the roots of the equation x square minus x root 2 minus root 3 equal to 0. Alpha is greater than b. A relation is given that Pn is equal to alpha power n minus beta power n. Then we have to find the value of this. First thing that might come to my mind after seeing a quadratic equation is that we might apply sum of root and product of roots or difference of roots, but that's not the case. Let's just put in the values of alpha and beta. Since alpha and beta are the roots of quadratic equation, the function will give a will be 0. So alpha square minus alpha root 2 minus root 3 equal to 0, and beta square minus beta root 2 minus root 3 equal to 0. Now subtracting these two equations, we get alpha square minus beta square minus root 2 alpha plus beta is equal to 0, or this is a square minus b square, so alpha plus beta into alpha minus beta minus root 2 into alpha plus beta equal to 0. Sum of roots is root 2, so alpha plus beta is not equal to 0, so alpha plus beta into alpha minus beta minus root 2 equal to 0. Alpha is not equal to minus beta, so alpha equal to beta plus root 2, or alpha minus beta equal to root 2. Now Pn is equal to alpha power n minus beta power n. Since we have to find a relation between P10, P11 and P12, we might modify this equation in forms of n plus 1, n minus 1 or n plus minus 2. We have the value of alpha square and beta square, so we can try and write this as alpha power n minus 2 into alpha square minus beta power n minus 2 into beta square. Value of alpha square is alpha root 2 plus root 3, so alpha power n minus 2 into alpha root 2 plus root 3 minus beta power n minus 2 into beta root 2 plus root 3. Opening this, we get alpha power n minus 1 into root 2 plus alpha power n minus 2 into root 3 minus beta power n minus 1 root 2 minus beta power n minus 2 into root 3. Taking the common powers together, we get that we know that alpha power n minus 1 minus beta power n minus 1 is equal to p of n minus 1. So we can write this as root 2 into p n minus 1 plus root 3 into p n minus 2. P12, we have to find 11 root 3 minus 10 root 2 into P10. So let's try and substitute n is equal to 12 at first. P12 is equal to root 2 into P11 plus root 3 into P10. In this question, if we expand this, let's expand this here or here, 11 root 3 into P10 plus 11 root 2 into P11. I'm trying and taking 11 common here. P11 minus 11 P12 minus 10 root 2 P10 plus 10 P11. We have to find the value of this. This looks similar. If we multiply this equation by 11, we get 11 P12 is equal to 11 root 2 P11 plus 11 root 3 P10. This is equal to this. So this value will come out to be 0. So we only have to find this value. 10p11 minus 10 root 2 p10. So let's try and substitute n is equal to 11. p11 is equal to root 2 p10 plus root 3 p9. We have to find 10 p11 minus 10 root 2 p10 because this value is 0. Let's multiply this equation by 10. So 10 p11 minus 10 p10 root 2, I took this here, is equal to 10 root 3 into p9. I am getting this as the answer, option B.